Good afternoon to all. Thank you so much for having us in this workshop. So we are presenting a project that we developed here in Viseu, in Polytechnic of Viseu, on the Polytechnic University of Viseu. I'm with Elizabeth, but we are a broader team of a lot of people from the University of Coimbra, like José Baranda and Miguel Almeida that spoke yesterday about rural fires. So we are going to present some knowledge attained with this project that was driven because we live in Mediterranean and for the is a hotspot by the, defined by the IPCC because of the climate change consequences. So we have a lot of droughts and heat waves, and of course, one of the main problems here in Viseu that we live close by is the intensity of rural fires. So we try to work with several partners here in the community to develop this project and increase the awareness of the people in our area. So this problem, as already probably know, of course, but here in the neighborhood, one of the main problems, as you can see in this graphic, is this yellow bar in that this graphic represents the causes of the rural fires here in Portugal. This data is attained by our national forestry ministry, and what you can see here is several causes like natural accidentals, but the main cause is the use of fire. That is very representative. This is the percentage. For instance, in 2018, 72% of the fires were caused by use of fire. And this use of fire, you can see that here we have the blue line is the average, but is the specific data for the burning of forest and agriculture surpluses are the main causes of the rural fires. So what we try to and we already know, of course, that the fire occurs because there's no proper management of this fuel that is in the forests, and the owners of the forests and from the agriculture fields try to burn their surpluses, and is the cause that main produces the rural fires. So of course, we with this project we try to create some awareness to the proper management of agroforestry fuels, and then we studied energetic valorization and material valorization of these agriculture residues and forest residues. And it is a specific spot that is Budiosa Residual Biomass Collection Center that we have here in our region. That is a collection center where the owners and the cleaners of the forestries can deliver their forestry residues for proper management. But in this collecting center, it exists still 2019, and now it is all the agroforestry residues that are collected are sent to a biomass power plant also nearby. So we try to study another ways to manage these kind of agroforestry wastes. here we have a little movie about these collection centers, these residual biomass collection centers. I'm going to show you. I don't know if you can hear the sound. Yes. The movie still goes on, but I think you got the idea. That is a collecting center where people these owners, they can put their surpluses there, and then it is um, organized in order to avoid, of course, rural fires. Then these surpluses are valorized, namely now by energetic valorization. Um, Only to show you the region I'm talking about, this is the Viseu area where we are. Here is Portugal. This is a zoom in of an area of Viseu. And this is the soil occupation. Here you can see the darker green, there are the density, this figure, the central figure is about the broadleaf trees or vegetation, and the right is the resinous trees. Um, about this occupation, we can know the amount of disguised forestry waste that are produced annually, because we can know the species that are there and the amount, and then the surplus that they produce. This is the characterization of the area about the forestry, and here is about the agriculture occupation in the darker red. You can see where the agriculture is in our region here. Here also is a map where you can see 3 collection centers of agroforestry wastes. We studied the Budiosa collection center, but is another 3. And here is the biomass power plants that is now receiving these residues. Um, but as I told you, with our project, we try to, one of the main purposes of the project was to go near the producers of agroforestry residues and try to incentivize them to put the residues and show them the benefits of the collecting their residues instead of burning them. And also here you can see the other objectives of the project, to do the physical chemical characterization of the biomass that is deposited in the collection center. Then we also did an assessment, try to assessment other ways of biomass valorization, namely by composting and mulching. Also analyze other energetic valorization potentials for local uses, and then try to analyze with the life cycle assessment tool the methodologies that have less impact, environmental impacts. And of course, as I said previously, the definition of good practices and design and operation of forest collection centers, and do the information and the operation of these collection centers in order to mitigate the risk of forest fires. I'm going to show you also, these are some pictures of the wastes that are collected in the collection center. And we did the characterization for since 2020 until 2023. Here you can see about the chemical characterization. We characterize the amount, but also the species that are more that we can find in the collection centers. Namely, the most relevant is Pinus pinaster, that is very abundant here in our region, but also with oak and eucalyptus, not so much eucalyptus, but also the agroforestry that rise from pruning in the agriculture is what was found, namely for citrus or vitis vinere from the wine production, or even from olive oil production. So these are the results of the cleaning of these fields, agricultural fields. Here are some estimations. Here you can see estimation of the amount that is being produced, that was produced all around this period of analysis that we analyze. Of course, when reduced is because the amount that was in the collection center reduced, because it was collected by the biomass power plant to be used there. But here we can see the amount since the beginning of the exploitation of the collection center, the amount of agroforestry residues that it were delivered in the biomass power plant. It was around 1,800 tons of agroforestry, and is very good for the parish, because of course the biomass power plant pays for this waste, so it's very good also for the parish to manage this collecting center. Of course, previous to go to the collection, to the biomass power plant, the bio waste, the agroforestry must be shredded, and then they are collected. So this was the first task in our project. Now I'm going to pass to Elizabeth. She's going to talk about the second task.
Okay, good afternoon. We in the second task want to study the composting process. So to do that, we make 3 piles with 2 meters of base and 1.5 meters of height. One of the piles, you can see the pictures. One of the piles have only residual biomass and no controlling process. We don't make the aeration or the watering. And another pile have only residual biomass, but we turn the pile periodically and addition water. And another pile, the first pile, was a mix between residual biomass and sweat sludge. So we made the analysis of compost that we obtained after 120 days. And we compare this compost with one from the commercial fertilizer that we buy, and we compare also with the ordinance, because in Portugal we have a regulation. In this regulation we have 7 groups of fertilizer materials, and the compost is inside of group 5. So from the 3 piles we can see in this table that we have similar parameters, values from the three piles about moisture. Um, Organic matter, we can see that the piles that without controlling have a higher organic content, but the pH is an important parameter, is similar, and are between the ordinance value that are in the ordinance. Another important parameter is the germination index, and we can see the highest value for the residual biomass without controlling. We also made the analysis of nutrients and heavy metals, and we can see that comparing with commercial fertilizer, our compost is good, have nutrients in a high value, and from the heavy metals concern, because is a problem in some compost, we can see that our compost is classified as class 1. In the ordinance we have 3 classes, and class 1 is the best classes. So this compost can be applied without concerning.
So now our third task was to study the valorization and energetic valorization of these agroforestry residues in local processes. For this, we worked also with the Universidade de Coimbra, that is trying an equipment for local uses and that uses lower amount of agroforestry. And we try to study although we know that the biomass must be splintered and low amount of moisture, we try to study the best amounts of and characterization of this wood. If we need to do pellets, or if we can use the wood chips, there's still going on this study. But I'm not only to show you our interest is to use these kind of equipments in local uses, like multi-sector applications, greenhouses, hospitality, food and biotechnology industry, instead of using natural gas that is a non-renewable fuel. So, but this is a work that I think that is going to be presented in the next workshop, not tomorrow, but I think there will be another workshop from BioRural, because we are working with Sivan, and they will talk about more about these tasks. So I'm going forward my presentation and leave to Sivan in the next workshop this information about this work. But also another task was to evaluate the environmental impacts of these methodologies that we are also studying. So to remember, composting, mulching is only the distribution of our agroforestry after shredding in the soil, in the forests, and also the actually valorization of energy in the biomass power plant. We used CIMA Pro software to do the life cycle assessment of these 3 methodologies, and only to present the broader conclusion is here. What you see is in the negative part of the graph is the benefits of using wood chips and agroforestry wastes instead of natural gas as fuel for electrical consumption. Okay, so we use this methodology, use as to compare the same production of energy by natural gas or by wood in the biomass power plant, or use this agroforestry for composting and mulching. And what you see with this graph in the negative part of the graphic is that the methodologies have a good impact in all the categories. The categories are what you can see above the graphic, namely abiotic depletion or green global warming or ozone depletion. These are the categories that were studied to evaluate the impact of these methodologies. And you see that almost then the composting, the mulching, or the energetic valorization of these agroforestries have good impact in all these categories, with the exception of the energy production, namely in the global warming and acidification, and eutrophication. These are the bars that are in the positive part of the graphic. So, of course, this has a lot of more things to talk about, but now here we are only presenting the overall data, okay? And then the last task, it was the share of the good practice communication and awareness of the users of the collection center. So we also produce a web page for the producers, the persons that go and put their agroforestry wastes in the um, in the collection center to come to this page that can be assessed by the mobile phone, and they try to put the amount of the waste they put in the collection center, and some information and some data for the people to put more to become more awareness to this kind of practices.
So before we finish, we want to invite you to submit some works that you made in the Green Week that will be in June in Politecnico Viseu. So if you want, you can until 6th of April send your submissions, your works. Thank you.
Thank you so much. Thank you.